Hello everybody, this is Brian from the Delta College Planetarium. Have you ever seen a shooting star? I didn't see one until I was about 16, so it might not be crazy that you haven't seen one in our ever more light-polluted skies. Shooting stars are not really all that rare. If you're outside on a clear night for long enough, the odds are reasonably good that you'll see one. They can occur anywhere in the sky and at any time, but there are times during the year when you're more likely to see one. Actually, shooting stars have nothing to do with stars at all. Shooting stars or meteors happen when a bit of rock, the meteoroid, frequently no bigger than a tiny pebble, crashes into the Earth's atmosphere. The meteoroid slams into the air ahead of it and compresses it so quickly that it begins to glow. It's so hot. The heat from the compressed air radiates back onto the meteoroid, and it too heats up and begins to disintegrate. The whole process takes a fraction of a second. The resulting momentary glow is the meteor. Because the meteor is moving so quickly, that glow takes the form of a quick streak of light. Frequently, these streaks are faint and short-lived. Occasionally, a slightly larger meteoroid will produce a bright, long, and lasting streak across the sky. Sometimes these can even have color to them, frequently a little bit greenish. So where did all these rocks come from? Well, they mostly come from three sources. First, they could simply be bits of stuff from the origin of the solar system that just happened to not end up in another body like a planet. A small fraction of the stuff from the original solar nebula remains out there, and sometimes it finds its way to Earth. Second, they could be debris from a collision of two other solar system bodies. Frequently, these are from asteroids crashing into each other in the asteroid belt. Those impacts send clouds of small particles scattering through the solar system. Less frequently, an asteroid might impact a planet or moon. These high-energy impacts can eject small rocks from their home bodies, careening through space. We know this happens because we've discovered meteorites on Earth that chemically match rocks from both the Moon and Mars. Yes, there are Mars rocks here on Earth right now. Finally, there are objects in the solar system that have a habit of continually spewing dust and gas into space. We call these comets. Comets are bodies of ice and rock from the outer solar system. When they travel closer to the Sun than about the orbit of Jupiter, the heat of the Sun begins to heat the surface of the comet, and it starts to melt. However, the ice in the comet doesn't turn into liquid, it turns into gas, blowing out from the comet and carrying bits of rock with it. From Earth, we see the gas and dust as the comet's long tail. Comets are wonderful sights in the night sky, and bright comets are a rare treat for sky watchers. But all that dust and gas doesn't simply disappear. These clouds of cometary debris are left out there circling the Sun. And if their original comet had the right kind of orbit, Earth can pass right through one of these dust clouds. An observer on Earth might see dozens, even hundreds of meteors every hour. This is a meteor shower. Meteor showers are relatively frequent events. There's about one per month, but they vary in intensity. The strongest and most famous meteor shower is the Perseid Meteor Shower in mid-August. We name meteor showers after the constellation the meteors appear to radiate from. Remember that these particles are still in orbit around the Sun, so while you can see meteors anywhere in the sky and moving in any direction, during a meteor shower, most of them will appear to be coming from the same direction. For the Perseids, that's the constellation Perseus. Perseus is rising after midnight in mid-August. In fact, to see most of any meteor shower, you will need to stay up past midnight. It's a little like driving in the rain. If you look in the rear windshield, you will see some raindrops hitting the glass. But if you look forward in the direction the car is traveling, hopefully, you will see far more drops as the car plows into the rain ahead of it. So when is an observer looking in the direction Earth is plowing through the cometary debris cloud of a meteor shower? Earth orbits the Sun counterclockwise, and Earth rotates about its axis counterclockwise, both as seen from the North Star. We can quickly see that at midnight, when you are looking east, you are looking in the direction the Earth is orbiting the Sun. Meteor showers are therefore after midnight events. Now that we know when we should go out and see a meteor shower, what are the best ways for us to see it? Do you need a telescope to see a meteor shower? No. Meteor showers are big events, and they take place over the entire sky. And each meteor itself is a very quick event. You'd never be able to point a telescope onto a meteor before it faded away. But telescopes are cool, and you can see a lot of other cool things with them, so, take that telescope out and go explore the universe. I'm never going to tell you to not take a telescope out, but it's not going to help you with a meteor shower. A way better tool is a nice reclining chair or a blanket. Lay back and try to observe as much of the sky as possible, keeping in mind that most of the meteors will appear to radiate from Perseus in the east. Faint meteors can be washed out due to moonlight or local light pollution, so it's a good plan to find someplace dark. Lots of local planetariums and astronomy clubs like to plan events for the Perseid Meteor Shower, so do a little searching and you're likely to find a group of like-minded people nearby. And that's pretty much all there is to it. So when the Perseids peak around August 12th of this year, go outside and just look up and enjoy the cosmic show. This is Brian from the Delta College Planetarium, wishing you clear skies.